Well, it's day 4, and we got a lot to do today. I thought about how to do things today. I was going to try something different. So I think what I'll do is go through all the figures and then have a separate video for each one because I'm not sure we're going to have time to do everything. Now, don't worry about that. I'm going to give you a copy of all the code for the final day, and you'll be able to play with it. You can add stuff to it, and I'll talk about that on the final day too. I'll have a video for you about that. But mainly, what I want to do today is have you understand how I make these different things. And so we'll go through all of them first, and then I'll have some separate videos to implement the code for each one. Okay? I hope that sounds like it'll work out better. Now, um, yeah, let's just go ahead. That sounds good. Okay. So we're going to do swirls, mandalas, hearts, flowers, and faces. The swirl looks like this. The swirl is created by rotating a Bezier curve around a common center point. And for ease in the calculation, we're going to translate the coordinates to the center point of the swirl like we did in the polygon and some of the other things we've done. And this makes it similar to the 2D systems that you're familiar with from algebra, where we have a central y-axis and a central x-axis, and we have the 4 quadrants, and now we have negative coordinates. So again, we've done this before, so it should be pretty straightforward. This is really similar to the cobweb, where we created the spokes that go from the center to the vertices on the perimeter of the circle that has the radius of the figure. Only now, instead, we're going to use instead of straight spokes that we have in the cobweb, we're going to use the Bezier curve with 2 control points to get these S-shaped curved spokes. So here's how this works. We're basically drawing from the center to a point on the radius, and we've used the code we've seen before to determine that. And then we have these 2 control points, and the further the control point goes from the axis, the deeper the curve is. And so in the code, there's a random thing called curve depth that affects that. Once we have one of these drawn, we just rotate our system and do the exact same drawing again. And we do that as we go on around. So we draw all of the curved spokes for the swirl. Here's the code. It's pretty straightforward. As usual, we pass the graphic context in. This is going to be the center. The radius will determine the size. Of course, that's half the size of the figure. And then here, number of sides is really the number of spokes. Here's the curve depth. This is set up. When I first did this, I used 75 all the time. And then I added this code in to add some randomness to it. So basically, this math min takes whatever's smaller, 0.75, or the random value from 0 to almost 1 times 0.15. So this could possibly be bigger than 75. And so that gives us some randomness here. I'm sorry. It takes the minimum, so often this will be smaller than 75 actually. Sorry about that. Okay, we translate to our xy to the center to be 0, 0. And now we can take advantage of that, so we just move to the center point in the for loop. We draw the first Bezier curve, we stroke it, then we go ahead and rotate and loop through again, and then this code just loops and draws all the spokes. Okay, I'm not going to go and do the code like I planned. I'll have a separate video for that, so that'll give you time to do that. So let's go on with the next figure instead. The next figure is the mandala. This is kind of similar again to our polygon code. We basically use the cosine and sine like we saw before to generate the points on the circle with a common radius and center. And then instead of drawing those points to form the polygon, we use those vertices at the centers for additional circles. And these have the same radius as the internal circle, so that means that they're going to all be tangent to the center point. Here's the code for this. Again, it's pretty straightforward. You can see it's very similar to what we just looked at. Again, we go to the origin. basically we go ahead and again, you've seen this arc. So 0 negative radius, that's going to be 0x, and straight up on the y-axis, the radius. And then the radius here is the size of the circle we're drawing. So this first two is these x and the y, and then this is the size. And you should have remembered that 2 times math pi is a complete circle, and false means we're not doing counterclockwise. Here it doesn't matter which direction because we're doing an entire circle. So we draw the circle, stroke it, then we go ahead and rotate. So again, very similar to the swirl code. Instead of swirling spokes, we're swirling circles. They all have a common radius, so they intersect at the center point. So they're all tangent to the center point. Again, we're going to do the code here in a minute. I'm just going to go through all of these first, then have a separate video for each one. That'll be a little more flexible, I think, for this day, because I've kind of been ambitious. The next figure are the hearts. I figured if we were doing a greeting card, we had to be able to send hearts to people. And the way this works is we're going to use 2 quadratic curves to draw either side of the heart. And so these curves are going to meet here at the bottom tip, and the other point will be right up here between the 2 lobes. And so you can see that the control point is here, and they're symmetrical. So basically we draw a line here like this, and we use this control point to control it. And then we draw from here to the other end, and we use a symmetrical control point. So because these are going from the same place and they have a symmetric control point, they're going to be symmetrical to one another. Okay. Now, I actually used the heart from the PowerPoint library here, and it's shaped a little differently than what I'm getting. So my hearts are a little bit more pointy around this region, and it kind of suggests that what I need to do is go back and instead of using a quadratic curve with 1 control point, I need to use a Bezier curve here with 2 to get it to be more rounded. So that would be a good thing that you might want to do to try to upgrade the app, is to get the heart to look a little bit better. All right, here's the code. There's no function for this. This code is inlined right in our break statement. Again, we set the origin to the center. We save the context first and we restore whenever we do that. And in this case, because the code is inlined, it's right there. Normally what happens is we save and then we call the function to draw the figure and then we restore. But because this function is rather simple, this method, the code is real simple, I didn't write a separate function or method for it. The hearts and the faces, I started to add code that just randomly rotates them to make them more interesting. And one of the things we might want to do later on with the app is factor that back out and make that a global checkbox on the interface. And so then it wouldn't rotate the faces or the hearts unless the user had checked that to indicate that. But right now it does that by default, and you can't override that. So we move to our 0. In this case, the radius is below the center point instead of being a negative radius. That's going to be the point of the heart. Then here's our quadratic curve. It starts at this position and draws to 0 and minus 5 times the radius. So again, that's on the y-axis. And it's half of the radius, but because it's negative, it's up at the top. So this basically goes from bottom on up to the top, and then the control point is right here. And then the second quadratic curve starts at the top where the 2 lobes meet, comes back around and down to that first position again. And then we fill and stroke, and of course, whenever we save the graphic context, we restore it. So again, we're not going to put the code in right away. I'm going to do separate recordings for that for you. Okay, our next figure is the flowers. These are also made by rotating around the center point. These require several shapes. So we need to do a circle using our arc for the center, and then we're going to draw a Bezier curve with 2 control points for each of the petals. and then we'll just rotate and redraw. So here's the diagram of how this works. Sorry it's a little rough. I'm not real good at the PowerPoint drawing. But here you can see I had my center circle, and then I have my first petal with the two control points. Again, the control points are symmetric to the y-axis here, x-axis here. And so that's going to draw a figure that goes from here. And again, I calculated these points with the cosine and sine based on the center point here. So that actually is supposed to be a circle, and it's centered right there. And I calculated the endpoints that way. And then I just draw the Bezier curve between them. And then, of course, we rotate and do the same thing to draw the petals as we go around. So that turns out to be a really nice technique to get what's called radial symmetry, where we rotate around the center point. Many things in nature have radial symmetry, like starfish and things of that nature. So here's the first part of our flower code. And so we pass in the context, the center point, the radius for the whole flower, and the number of petals. I'm not sure why I set this up. I think I was playing around originally, and I thought that it wasn't going to work if I didn't have it to be an even or odd number, one of the two. And so I got it to work, and I didn't need that. So really, this is unnecessary. I just have an extra variable that has the same name as this, so we could just use petals instead of num petals. We go ahead and calculate the rotation angle. So we take a full circle and divide by how many petals we have. And then our center radius is going to be 1/4 of the larger radius. That seems to work pretty well. And I just kind of used that by example. I tried a few different values until I figured it out. I mean, I knew that I wanted the center radius to be smaller than this radius. So the idea here is that this is 1/4 of this whole distance from the center to the edge of the petal there. And in fact, I think I actually extend the petals a little further. So let's see if the code suggests that. We go to the center point. Here's where we draw the center of the flower. So that's centered on 0, 0. We use the center radius, and we do a full circle and false for the counterclockwise, although it doesn't matter which way we go when we draw a full circle. We fill and we stroke it. Now we do the petals. We start at a point on the edge of the circle, and that turns out to be directly above the center. So we have x0, which means we're on the y-axis, and then the P1, oh, I'm sorry. You know what? I think this is wrong. P1y is 0. That means 0 on the y-axis. And so P1x center radius is going to be over here in the east. So it's actually just like this diagram. Okay. And then we calculate the endpoint of the first petal on the edge of the circular center. That's going to be P2x and P2y. You've seen this before. We're using the cosine and the sine to get the x and the y given the radius. And we're using the center radius because these 2 points are on this internal circle. So we're going to draw from here to here, but we're going to use the control points to create the Bezier curve that draws really far out. Okay? Here we determine the Bezier curve points, the control points. So we have C1x and y, C2x and y for the 2 points. Notice I did extend the radius, so it's even 1/4 more than the radius. That's kind of hokey to do that, because that means now when we tell it to draw a flower a certain radius, it actually draws it 25% more. So that's probably something I should fix for documentation if I wanted to use this code otherwise. But it doesn't really matter here. It generates circles, flowers, and they look nice. Now it's real easy. We move to our first point, and we draw to our second point. So again, Bezier curve 2 starts at the point you're currently on, moves to this point. Here are the 2 control points. then we rotate and we do it again. So same technique we've used all along for all these figures that have radial symmetry. Okay, again, we're not going to do the flower yet. I'm going to do that in a separate video for you. Okay, next one is the faces. Originally when I did this, I just did the smiley face, and then I'm like, well, you know, people would want to send greeting cards with sad faces for things like illness or death in the family or a pet, things like that. So we should do that too. Like the hearts, the faces are randomly rotated when they're drawn. I've got that hard coded in now. That'd be something to change in a later version of this and let the user decide if they wanted them. In that case, they'd all be straight up and down. So you can see that I captured these from the actual output of the program, and they're slightly rotated. Okay. So faces are actually pretty easy to do, except for figuring out how to do where to draw and the sizes. And one problem I had, it actually took me longer to set the code up than it did for a lot of the other figures, because the way the graphic system works is it wants to keep drawing. And so you have to basically tell it when you're done so it doesn't connect the lines, so to speak. So in some of the earlier versions, I got the body, and then when I did the head, it would have a connecting line between the eyes, and then would have another line that connected to the mouth. And it took me a while to figure out how to get that to quit doing that. And you'll see in the code, the trick is that you just use the begin path, and then the path ends when you stroke or fill, which actually adds the color or does the rendering of the line, or when you use another begin path. So breaking down the face, the body is a circle. We have two circles for the eyes. We have an arc for the mouth. Now, there's certainly a lot more you could do here with this. So, you know, I could change the eye expressions. Right now, all my faces have the same body and eyes, and they just have a difference in the mouse. So I started with the happy face, then I added the sad face, and then I added a sort of grim or angry face with a straight mouth. Not sure what kind of message that would say with a greeting card, but you know, you could send a card with sort of a admonishment or something, you know. Okay, so again, we have one face function that draws, and then we tell it which of the three faces to draw, and that's on a switch parameter. If you don't pass that in, it defaults to doing the happy smiley face. So the code is kind of long, but it's not really difficult. So first thing is, here's the test to see if this face type is null. If it is, then we set face type to smile. Otherwise, we'll use whatever was passed in. So it could be smile, grim, or sad. Okay, we use a begin path. We set the center point to the center point that we passed in. Here's the random rotation that I mentioned that I put in here, which I want to move that out of here and make that a global option for the user. We begin a path. We draw the body here with an arc, and again, you know that 2 times math pi means a complete circle. So 0 to 2 times math pi will draw a complete circle. It doesn't matter if this is true or false because you're going to draw a circle either way. We fill the face and stroke it. Excuse me. It turns out that it's always better to stroke after you fill, because depending on the size of your stroke, the fill might overwrite part of it. So you want to always stroke the outline after you fill it. Now we do the eyes. And in figuring out the eyes, I kind of used a trick that I learned in my wood carving class, which is that the eyes are basically 1/5 of the width of the face. They have a space within them that's 1/5 of the face, and then a space on either side of the face that's 1/5. So I set the radius of the eye to work that way. And you can see what we're doing here is we're just calculating. Now, the eyes are going to be in the same Y, but the left and right will have a different X, right? So we calculate those. We begin the path. We draw the left eye with the left X and the IY. Notice the radius divided by 5. And then a 0 to 2 math pi means a complete circle. Again, the false doesn't matter here because I'm drawing a complete circle. So again, the radius is the radius of the body. And so 1/5 of that means that the eye will be 1/5 of that. Okay. And then we draw it here with the stroke. Now we go to the other eye. We go ahead and calculate its value, X value, begin a new path, draw that one and stroke that. So at this point, we've drawn the body and both of the eyes. The code continues here. Here's the switch. The only thing that's different between the different types of faces is the mouth. So we pass that in here as the face type. And whoops, sorry. That can either be smile, grim, or sad. And then the code will switch on that. And so if this is smile, then it'll go ahead and draw the smile mouth. If it's grim, then it'll calculate the values and draw the grim mouth. If it's sad, it'll draw the sad mouth. So the smile mouth is really straightforward. Again, we're using the arc, but this time we're not drawing a complete circle. And this code took me a long time of trial and error to figure it out. So we start at 1/8 of a circle. 2 times math pi is a complete circle divided by 8. And we go to 6/8 of a circle. And one of the reasons this was difficult is every coordinate system that I know that uses this kinds of coordinates puts the 0 point in the north, but this HTML5 canvas puts it in the east. And so I had to figure out how to get these to start in relation to that. So we move so far around from the east, begin the mouth, draw it up to so far around for the second parameter, and that gives us that, okay? And then the mouth is set on, let's see, so 0 is the x-axis, so that means it's centered vertically, and then radius divided by 10, it means it's a little bit below the center. So to draw this arc, it's part of a circle. The center point for the arc is a little bit below the center of the face to make it position right, okay? The grim mouth is just a straight line. So we just calculate the position. We move to the first point and we do a line to the second one. And then the sad mouth is the reverse of this arc. And that's there, okay? So there's our face. Again, we're going to have separate videos for doing all the drawing here. Okay, so I'm going to finish this video and then I'll start the individual ones to do the parts for you.